All right, so as I said, we are talking word problems today. So we have three formulas that you must know, so you got to memorize these three formulas. The first one hopefully is familiar. We taught you this one back in 9th grade, y equals a times b to the x. A stands for your initial amount, or your starting value. So that's just how much we begin with. So if we're talking about our population, it's the population at the start of the problem. We're talking about how many bacteria we have, it's the number of bacteria at the beginning. So then B is your growth or decay factor. If it's a growth problem, your B value is 1 plus your rate. Your rate would be a percent, but we always use the decimal form of our percent. If it's a decay, it would be 1 minus your rate. And then there are just a couple of exceptions. If it talks about, for example, doubling, your B would equal a 2. Tripling, your B is a 3, so on and so forth. And the other one that we've seen a few times is our half-life. So our B value would be 1/2. So if it's a percentage, you either have to add it to 1 or subtract it from 1. Doubling, tripling, half-life, I'll tell you what number you're going to use. So X is your number of times that it happens. So if it's like population is doubling every year, so X would be your number of years. That's how many times it doubles. Or if they talk about it in terms of months, you would put the number of months that they're dealing with. So it depends on the context. So that's why we say X is the number of times it happens. So then Y is just your new amount. What does it end up being at the end? So again, that's the one we've done before. Y equals a times b to the x. So now our next one here is our compound interest formula. It's very simple, or it's very similar to our y equals a times b to the x. So here where we would normally have the letter A, they just use the letter P instead because this is always dealing with finances of some kind. So P is your principal. That's what they call it. Your principal is just your initial amount. How much did you start with? A lot of times it's dealing with some kind of deposit into a bank account. That would be your principal amount. But it's your initials. What you start with, it's just like your letter A. So then this whole parentheses here, that basically makes up your B value. Since it's dealing with compound interest, meaning you put money into an account, you're earning interest. That's why it's always going to be a plus for that. So R is your rate, just like it was before. We want to use the decimal form of that rate. So that's why I say R is rate as a decimal. We always want to use the decimal form of it. N is the number of compoundings, meaning how many times are you earning interest in 1 year? Which leads me to my little chart right there. If you are told that your interest is compounded annually, that means you earn interest once a year, so your N value would be a 1. Semi-annually would be twice a year. You ever hear a store talk about a semi-annual sale? That means they have it twice a year. Quarterly, how many times would quarterly be? 4. So every 3 months, 4 times a year. Monthly would be 12. Weekly? Good. I've had people in the past tell me 50, and it makes me cry a little bit. There's 52. And then daily? 365. So that's what your end values would be based on those words. So you would read your problem, figure out, well, how are they earning interest, how many times a year, and that gives you your end value. So T is your number of years. They're earning interest for 5 years, 10 years, 30 years. T is your number of years. And then A is your new amount. That's how much money they have at the end of the whatever years. 5 years, 10 years, whatever. And then our last one is if you are earning interest continuously. That's the key phrase for this one. Is it'll tell you continuously compounding interest. So if it's continuously, you use this formula that I like to call APERT. It looks kind of like PERT. Just like up above, your principal is your letter P. That's still what you start with. That's always going to be the same no matter what letter they decide to put there. Anything in front of the one that has an exponent is always your starting amount. R is your rate. Again, you'd want to use the decimal form of it. The one thing about your rate, though, on the letter E is if it's growth, it would be positive. If it's decay, you would just make it negative. So if you were losing money on your investment, you wouldn't do 1 minus your rate. You would just make your rate negative. So if you were losing, say, 10%, your exponent would be negative 0.10. So you just make that value negative on your continuous. T is your number of years. A is your new amount, how much we have at the end of the problem. And then E is just E. It's that button we learned about last time. It's in our calculator, which is approximately 2.71, so on and so forth. It's that irrational number we talked about last time. So those are the 3 formulas we're going to be using. We're going to go through some practice problems. Start learning how to decipher which of the 3 we want to use. So here's our first one, talking about population. The population of a popular town of Smithville in 2003 was estimated to be 35,000 people with an annual rate of increase of about 2.4%. So what is the growth factor for Smithville? Now, a lot of people want to tell me 2.4%, which, okay, yes, that is a portion of it. But your growth factor is going to be 1 plus your rate as a decimal. So 2.4% as a decimal. You would move that over 2 places to the left. So I get 0.024. So 1.024, that is our growth factor. That's what you're multiplying by each time to get you to the next value. So write an equation to model future growth. Now, since this is population, it has nothing to do with interest. This is our first formula we talked about on the front, y equals a times b to the x. So our A here is going to be the 35,000, because that's how many people we started with back in 2003. B is our growth factor, which we just found to be the 1.024 number. And then X is going to stay as X. We don't know how many years. It just said write an equation to model future growth. So we leave that as X for right now. So in C, use your equation to estimate the population 2007 to the nearest 100 people. All right, 2007 is how many years after the start of this problem? 4. So it started in 2003. We were up to 2007. So that means I'm going to plug in a 4 for my exponent. 35,000 times 1.024 to the 4th. Let's see what we get. All right, so let's write that whole decimal. 38482. 0.90697. So we just have to take care of our rounding. They wanted us to round to the nearest 100 people. Now you have to be careful. We're used to seeing hundredth with that TH at the end, telling us it's 2 numbers after the decimal, but they don't want that this time. They want the nearest 100. So that 4 is currently in our hundreds place, so that's where we want to round to. So the 8 means the 4 is going to turn into a what? A 5. So it'll be 38,500 people in 2007. Taking a look at our next one, talking about depreciation. Matt bought a new car at a cost of $25,000. The car depreciates approximately 15% of its value each year. So what is the decay factor for the value of this car? So since this one is decreasing, our decay factor would be 1 minus my rate as a decimal. So 1 minus my 0.15, because it was 15%. So as a decimal, that's 0.15. So subtract those two, we get 0.85. So our decay factor is 0.85. So again, this is going to be our A times B to the X, because we're not dealing with interest. We're trying to figure out the value of a car. So our A will be the 25,000, because that's how much you bought it for. Our B value is the 0.85 that we just figured out was our decay factor. And then it's to the X power for now, because we don't know how many years we're looking at yet. But then in part C, it tells us to figure out how much the car is worth in 10 years. So we're going to raise that to the 10th power. So 25,000 times 0.85 to the 10th. So 4921. So there's all the decimals calculator gave us. Now, we're dealing with the value of a car. Did they tell us to round anywhere specifically? Nope, nope, nope. So whenever we're dealing with money, how many numbers do we normally have after the decimal? 2. So 4,921.86. So that's how much the car will be worth after 10 years. So then in 2007-2008 academic year, the average cost for 1 year at a 4-year private college was $23,712, which is an increase of 6.3% from the previous year. So write an equation to model future growth. All right, so if it continues along in this trend, future growth means I would do 1 plus my percent. So it would be the $23,712 that it costs this year times 1 plus my 0.063. Now we could leave it that way. You could also write it as 1.063, actually adding together what's inside your parentheses. You could do that also. So then part B, what is the cost in 4 years? So let's raise that to the 4th. And have you go ahead and practice typing that in your calculator. So in 4 years, if it follows that same percentage increase, it will cost $30,278.75 per year. So multiply that times 4, you're looking at $121,000 for 4 years. So now last part here, find the cost in 18 years. Raise that to the 18th power if you have not already. So you should have gotten 71,214.26. Which that number always makes me so scared because my children are only 4 and a year and a half, so it's like how much is it going to cost them? It's expensive. Then you multiply it by 4 years, that's like $280+ thousand for college. Yes, Jacob. There we go. Fixed my error. Actually, I typed in that 14 instead of a 12. All right, so that's our a times b to the x. Talks about percentages. There, as I said, you could see doubling, tripling. That's those ones. The other kinds of word problems we have always deal with interest. So you know you got to use one of the other 2 formulas because it's always talking about interest. So our first example here on our last page says, Jose invests $500 at a bank offering 10% compounded quarterly. Find the amount of the investment at the end of 5 years if it is left untouched. So our equation for this is A equals P times 1 plus the rate over N to the NT power. So our P, how much money does he invest? 500. So your principal is 500 because that's how much money he invests. Our rate is 10%, so that would be 0.10 in there for our R. It's compounded quarterly, so how many times a year? 4. And then T is a 5, because they want to know how much is there after 5 years. So he's leaving it in there for 5 years, he's not going to touch it. All right, let's type that into our calculator. So 500 times 1 plus 0.10 over 4 to the 4 times 5 power. So use that fraction. It's going to make things a little easier. Have it written in the calculator exactly how it's written on my paper. So I get 819.30822. So again, it's a money problem. They did not tell us to round otherwise, so we're going to go to 2 numbers after the decimal. That would be $819.31. Now, if they told me to round to the nearest dollar, then I wouldn't have a decimal in there. So our next one, Tamika invests $500 at a bank offering 10% compounded continuously. Find the amount of the investment at the end of 5 years if left untouched. So basically the same kind of problem as Jose. The only difference here is it's being compounded continuously. So whenever it says compounded continuously, that is our PERT formula. A equals P times E to the RT power. So our principal, yet again, is $500 because she's investing $500. E stays as E. That's how much, it's compounded continuously, so that's just E. Our R would be 0.10 because that's how much interest she gets. She gets 10% interest. And that's going to be times 5. So your exponent is 0.10 times 5. So remember, to get E, you have to hit second and then the ln button. That gives us our E. And then 0.10 times 5, 824. 260. So again, didn't give us anywhere specific to round to, so since it's money, we will go for 2 numbers after the decimal. So $824.36. So it's not much of a difference, but she did end up getting more money because it was compounded continuously, so that's always going to be a better way to go if you have that option. So looking at our last one, we're going to compare our compounded interest. So we're going to start with $100,000 in an account that earns 4% interest for 5 years. Determine how much money will be in the account at the end of the 5 years for each situation. So we're going to start with compounded quarterly. So that's going to be P times 1 plus R over N to the NT power. That's actually the same formula we'll use for B. That's the same formula we'll use for C. D is going to change though because that's compounded continuously. So our principal is $100,000. The 1 plus our rate is 0.04. The first one is compounded quarterly, so our n is a 4. And then our exponent is going to be 4 times 5. All right, let's type that in. There we go. We got 122,019. So for compounded quarterly, that would be $122,019. Because it would be 0.00 based on our rounding rules. So let's see what happens if instead of quarterly, we go for monthly. So again, it's going to be this same formula here. Our principal is still 100,000. Our rate is still 0.04. It's just we're going to change our n value to a 12 since it's compounded monthly instead of the 4 that we had for compounded quarterly. So the only difference is my 4's become 12s. So let's type that in and see what happens. All right. 122,099. $122,099.66. So in those 5 years, they'll make a little over $80 more going monthly as opposed to quarterly. So based on that, what do you think will happen if we go daily? A little bit more, probably. So again, same equation, only this time we are going to change from 12 to 365 for our daily. So 100,000 times 1 plus 0.04 over 365, raised to the 365 times 5. That one is $122,138.94. That's like $120 more than our first one. And so then our last type, compounded continuously. That's going to be our different formula. That's going to be our APERT formula, principal times E to the RT power. So again, our principal is still 100,000. E stays as E. Remember, that's a button in your calculator. And it's going to be to the 0.04 times 5 power. Let's see. Good. Times 3.04 times 5 power. 40. That one ends up with the most at $122,140.28. So if you're given a choice, you'd want to go with compounded continuously. You're going to end up with the most money in the long run there.